Alright, we're moving on now from our matrices section onto linear transformations. Now we will be using matrices in our linear transformations, but what we're going to be looking at now is just focusing on getting an understanding of what we mean by linear transformations, and then afterwards we'll utilise what we know about matrices. Okay, essentially you are familiar with what transformations are because we've done it in methods when we've transformed graphs, whether it be a quadratic, a parabola, or a hyperbola, or a truncus, or whatever. We've transformed it using a dilation factor, or translation, or a reflection. What we're looking at now is a similar sort of idea, okay, but we are moving, in this case, a point or a line or a figure from one position to another under some rule. Okay, and when we work through it, we typically use mapping notation. So this part here is the name of the transformation. Okay, T, for instance. It could be L, could be anything. Okay, that's the name, and we are transforming this here, the original point, xy, and it's changing into its image point, x prime, y prime. Alright, and we're just using this arrow just means that that's mapping onto this, according to this transformation. For example, okay, we've just got here a Cartesian plane. Here's our original point A, and it's being transformed to its image, x prime, y prime, or x dash, y dash, but we aren't given the rule. This is just what's happening. Okay, it's moving to a different position. Now, some examples of transformations are here. So we've got transformation T. The point xy is changing according to these two rules here. So the point x will be transformed by this rule, where x is being multiplied by 3 and adding to y, and this becomes the new x point. Okay, the new y point will change according to this rule. Okay, so we go 2 times x and we add 8 times y, and that gives us our new y point. This is a linear transformation because the powers of x and y in both of these rules here are linear, are 1. Okay, they're both linear expressions in x and y. However, let's have a look at the next transformation, L. The x and y coordinates are changing according to these rules: 3x squared minus y for our new x point, and 9 minus the square root of y for the new y point. Notice the power of x is 2 here, and the power of y is a half. So this is a non-linear transformation. This one here is a linear transformation because the rules that we're given, the power of x and y, well, there is no x in this case, but that's okay. It doesn't have to have an x or a y term, but the powers of those that are there must be 1. So the y is 1. This one here, the square root of 3 is okay, that's just a coefficient. The x, though, has a power of 1, same with y. So this is a linear transformation. And we've got this fourth one, transformation T, x and y are changing into these coordinates according to these rules: 2x plus 4xy, and then 63y for the new y point. This part here makes it a non-linear transformation because the x times y. Because if we had an expression, say x, y equals 1, then if we were solving for y, then y becomes 1 over x, and this we know is not a linear transform. This is not a linear expression, not a linear equation, because that can be also written as y equals x to the negative 1. Okay, non-linear. Okay, so hopefully that explains what a linear and non-linear transformation is. Alright, so let's have a look at what we've got here in these examples. Find the image of negative 3, 1. Okay, this is the original point. We want to find its image under these couple of transformations. So first of all, this transformation here, the rule is 3x minus y, 2x plus 8y. So it's this first one here. Alright, so instead of having x comma y, we've got negative 3 comma 1. So that's our original point. So the new x coordinate is given according to the rule 3x minus y. So 3 times negative 3 minus our y value, which is 1. Okay, so negative 9 minus 1 is negative 10. And so we have negative 10 here as our new point. And then our y coordinate, 2 times x. So 2 times negative 3 plus 8 times 1. And that gives us an answer of 2. So our image point is negative 10, 2. All right. Similarly, we do the same with this second one. Okay, so negative 3, 1 becomes 26, 8, according to these rules. 3 times x squared, so 3 times negative 3 squared. Negative 3 squared is positive 9. 3 9s are 27. Minus 1 is 26. And 9 minus the square root of y, the square root of 1 is 1. So 9 minus 1 is 8. Okay, I think that's fairly easy to grasp. Alright, so that's what, so as long as you understand what this means of noting or explaining what transformation is taking place, you need to understand that, then that's fine. Okay, let's have a look. Now, linear transformations follow this particular rule. So we've looked at a few examples. As a definition, I suppose, the transformation t, being a linear transformation, will follow this rule, where xy becomes a times x plus b times y, c times x plus d times y. So your new x coordinate is ax plus by. Notice the powers of x and y are 1, a and b are coefficients. And your new y coordinate becomes cx plus dy. C and d are coefficients, x and y have powers of 1. Okay, so a, b, c and d are just all real numbers. And that's what we mean by this statement here. So this means that x and y cannot have a power other than 1. Alright, we've talked about that. So we need to understand that linear transformations can be represented by a matrix. Okay, this is where the matrices come in. Our way of expressing it here as a transformation is according to that rule we've just seen, but it can be written simply in matrix format as T equals A, B, C, D. So your A and B correspond to the coefficients of x and y for your x coordinate. C and D here on the bottom row correspond to the coefficients of x and y for your y coordinate. Okay, so let's have a look at an example. Transformation T, where xy maps onto negative 30x plus y, root 7x plus 8y, can be written as T equals negative 30, 1, okay, because the coefficient of y is 1, square root of 7, 8. Alright, so that's just being able to write it as in matrix format. Alright, so let's have a look. We're going to use our understanding then of matrices to work through this particular example. Okay, use matrices to find the image of negative 2, 3 under transformation T, okay, which is from example 1. Right, so that's that transformation T here. We're going to use this particular transformation. So we've got this matrix. We're going to use that here to find the image of -2, 3. And this is how we started. Our transformation, T, it multiplies by our x, y coordinate, our original coordinate here, just written in matrix form as a 2 by 1 matrix. And that then becomes our image, okay, also written as a 2 by 1 matrix, x prime, y prime. So our transformation T as a matrix is here, -30, 1, √7, 8, multiplies by our original point, -2, 3. So it's always x on top, y on the bottom. And that then becomes our image point, x prime, y prime. So multiplying these together, so we go -30 times -2 plus 1 times 3 is 63. For our x coordinate, our y coordinate is √7 times -2 plus 8 times 3. Alright, so we're just leaving it in exact format, -2 √7 plus 24. That's our y coordinate. So this then is our this is our image point. Alright, so -2, 3 maps to 63, -2 √7 plus 24 under our transformation T. Alright, so that's there written in that form. Alright, so go back any of that if you need to again, and this is the end of this particular video. We'll pick it up again in the next.